from the heart of Dubai, where tomorrow is being built today, to the world. Welcome to the CTO Show with Mehmet. Here, we redefine technology and reimagine possibilities. With Mehmet, delve into the riveting realms of AI, cybersecurity, and digital technology. Experience the thrilling highs and lows of startups. Immerse yourself in the spirit of entrepreneurship and witness the future of business innovation being written in real time. Now, without further ado, let's tune in and explore the future.
Hello and welcome back to a new episode of the CTO Show with Mehmet. Today I'm very pleased joining me from the US, Björn Kolbeck. Björn, the way I love to do it is I keep it to my guests to introduce themselves. Tell us a bit about your background and what you are up to today, and tell us also about your company.
Hey, Mehmet. Thank you for having me on the show. I'm Björn Kolbeck, co-founder at Quobyte. I started my career as a coder and then moved more into the other roles inside a company. So I think I spend a lot of time in sales and marketing today. But my background is actually software engineering. So I studied computer science in Berlin, then moved on to do my PhD at one of the HPC centers in Berlin. It's basically a supercomputing center that also did research in distributed systems. And that's where I met my co-founder, Felix. And within our project, the idea for Quobyte was born. We worked on created a project called XtremeFS, an open source distributed parallel file system for grid computing, as it was called back then. And that was, in the end, the foundation on which we built Quobyte later. Before we started Quobyte, both Felix and I worked for Google. There was an inspiration, a sense of how to run infrastructure at a very large scale and how to do it in software only. And with this background, we decided to start Quobyte to bring this kind of approach to the enterprise. So on the one hand, the idea was that HPC scale-out workloads will come into the enterprise, which happened. If you think about machine learning as the latest scale-out workload in the enterprise. And then the other aspect was that we wanted to give enterprises the ability to run their infrastructure like Google. So software-based, very scalable, and small teams can run really hundreds of petabytes of data infrastructure.
Great.
But in a nutshell.
Great. I will go deep dive also a little bit more, but just a question that sparked in my head, because I was telling you before we started even recording this episode today, I work in infrastructure for I would say more than 10 years. And whenever I used to see something cool coming out, especially in that domain, people it looks like Google is a school where, a lot of people, they graduated from there with these, super cool ideas of how they can modernize, the infrastructure, especially when it comes to the storage and, the systems in general. So you must have seen, some, I would say, challenges that usually the enterprise face in the storage industry that you said, okay, maybe we can, whatever we have learned, from that school, and also the other available resources that were available to you at your co-founder, Felix. So what were the main reasons that drove you to choose specifically to solve, the challenges of the storage industry?
Mm-hmm. So my background is in supercomputing, high performance computing. And while that, let's call it an industry, is used to software storage. So if you know the Lustre file system, it's all in software, it's scale out. They always lacked the reliability part. So it was all about being fast, but not reliable. And that basically kills you at scale, because the bigger your storage gets, the more failures you will have of hardware. So they always struggled with, keeping the systems running, usually solving the problem with an army of PhD students because they're cheap labor. And then on the other hand, you have the enterprise storage. Back when we started XtremeFS, that was in 2006, we were PhD students. Enterprise IT was still, VMware, SAN storage, Capacity is measured in gigabytes. There is no shared storage. It's all geared towards transactional databases. Interestingly, I think not a lot has changed in enterprise IT. It's still very much focused on this kind of use case. And then you have the scale out use cases. First, it was things like Hadoop, and now it's machine learning that don't fit the typical enterprise IT model. And you just have this clash of cultures. So for us, it was clear that if you want to get those scale out workloads into the enterprise, you need storage infrastructure that's fast, like high performance computing, but reliable, like Google has it. And in the end, this mismatch is still here today. That's the interesting part. People still think they can solve scale out workloads with their traditional storage. So, we started 10 years ago as a company, but people still hold on to those old ideas. They're slow to die, I would say.
Why do you think that, Björn? Like, I used to face this. I faced the same when I was sitting on that side of the table, and then I became vendor also as well. So why do you think enterprise moves slow on the storage adoption, and then the innovation that comes there? Although to your point, now you mentioned like machine learning and these new workloads, they need actually something reliable to your point. But why is that, and how do you think we can change this culture? Maybe I would say
it's a very good question. So why is it? I think it's because when the car came, people said, "Why do we need cars? We have horses." Never touch a running system. There are so many aphorisms out there that describe the situation. I think data is particularly difficult. I don't know who it was, but someone said data or storage is the only thing that needs to work when you switch off the lights or the power in a data center. You can rip out networking. You can easily replace compute with new servers. But when your storage fails, as in losing data, you have a very big problem. So people tend to be conservative when it comes to storage. On the other hand, you have been in infrastructure. Keeping infrastructure running is often you spend a lot of time firefighting and keeping the systems running. So the idea of wanting to change doesn't come from necessarily the people that run the storage. But then you have the users that are demanding new storage, or they need it to run their workloads. If you want to really feed your GPUs, keep them busy for your machine learning, for deep learning, you need storage that's able to scale out and be very fast. So there's a bit of a mismatch. And what I've noticed is that the forward-looking IT folks, infrastructure folks, they definitely look into solutions to provide better scale out to their users. But often it's a bit of a fight. And that is, as a vendor, you're kind of in the middle. You have to work with both. But change is coming whether they want it or not.
Cool. Yeah, of course. Like at some stage, people cannot deny that you need to do the change. Like you can resist it for a while, but after that, you need to do the change. Now, coming back to the concept of software-defined storage, and out there are a lot of maybe, and I'm sure I've faced this, and it's normal to have, I would say, kind of already existing market when you bring something new to the table. But for you, what is, like, for example, if we can call it the competitive edge, or where you saw like what you offer would be beneficial? And was that like specific to a certain industry, or like, we can generalize it to anything that can run these workloads?
Yeah, let's start with the industries. I think storage is everywhere, and we cater to a broad range of industries. Our customers are in life sciences, media and entertainment, finance, traditional research. So it really depends more on the use cases. So wherever you have the intersection of a lot of data plus performance requirements, we fit in very well. And the drivers are different. So in life sciences, you have, for example, newer microscopes. They are automated. They have high resolution cameras, so they generate tremendous amounts of data every day. in media and entertainment, it's the high resolution 4K, 8K video where you suddenly need HPC infrastructure to do video editing. In finance, it's a lot of machine learning, autonomous driving, all machine learning. So it's different drivers, but in the end, the underlying problem is always the same. And then the software approach, this is where we have to take one step back and ask about, what is software storage? Because software-defined storage was so overused. So I heard one vendor say, we are software storage because our engineers develop software that then runs on our appliances. That was a very weird way to put it. And I think that's why we shifted towards saying 100% software storage. Because for me, the beauty of software is, you have a generic server. You download MySQL. It turns into a database server. I don't know, you run a UI and a web interface on it, and it is a workstation. So the software defines what the server does. An appliance is the antithesis of that. So software storage should be something that you can download and install and then turn the server into a storage machine. That's what we do, but I don't think others are doing it. They have even if they claim their software, they run on appliances. They tell you, yes, we're software, but you can only install us on this one server and this one appliance that you need. So you lose the ability of software that's so great to download and turn any machine into software, into storage.
So for you, I can understand, Björn, like you don't, of course, there must be some specification, but you don't limit the model or, right? Is that the case? Now, yeah. I think the issue here is the word storage by itself became so in the mind of people, kind of a commodity. So people, they think, to your point, like about it as it's just they're buying, a chassis and it's just a commodity. And when I, had a look on your website, so you emphasize a lot about like you are providing software only, which is great. And I can see also like you can run on, anything. At the same time, you can provide any protocol. Can you for example, tell me a little bit more about, maybe it's a little bit deep technical, I know, but on a high level, the different use cases. So we mentioned, of course, like high performance computing, and we mentioned, machine learning. But if I want to put it in an enterprise grade solution, so can I cover all my workloads? If you can walk me through the use cases from that perspective also, Björn.
Yeah. So Quobyte is a parallel POSIX file system. So it just looks like, NFS or your local file system, which means you can basically take any application and run it on Quobyte. And then in terms of workloads, we built the system in a way that we can support the different workloads that you have, whether it's, a lot of small files, which is a lot of the AI workloads. You need low latency for that. Random IOPS, so basically databases or VMs that modify tiny blocks and overwrite them. And then also the throughput workloads like Hadoop or traditional HPC or video streaming. And then we support flash and hard drives. We decided that both storage media is important. Of course, flash is great for performance. It's the modern thing. You want a lot of flash, but hard drives allow you to do things cost effectively. They're still, after 10 years, they're still 5 times cheaper. So this combination allows you to then really run a broad range of use cases on Quobyte. And the idea is software or storage infrastructure. So that you can basically, from your Quobyte cluster as an admin, you can provide your users with different kinds of storage depending on the needs. So you can do the high performance scale out storage that they need for their AI workloads. At the same time, you can provide cheap and deep archiving, cold storage on the hard drive tier. And when you can deliver different types of storage from the same storage cluster, you get great efficiency because you basically have to manage one system only. You can share resources. We built Quobyte with things like multi-tenancy, oversubscription, and so on. So in the end, you can provide storage as a service like on the cloud, very fast, different use cases, very efficiently. I think it's 2 or 3 steps away from where people are today with appliances that are very focused on different use cases. But in the end, this kind of storage infrastructure is what you want as an admin because it makes your life much easier.
Absolutely. Now, you mentioned something which I was trying to ask you about. So you mentioned the cloud. So someone might ask, okay, but doesn't the cloud, hyperscaler, they provide me the storage? So why still I need to use your solution, for example? And of course, I know the answer, but I'm asking this for the audience.
Yeah, it's a very good question. The first one is that if you want to run scale-out workloads on the cloud that use a file system, most cloud providers don't have a good answer. So we have customers that use us on the public clouds, and they love the performance and scalability there. And the other aspect is that the cloud quickly gets very expensive, especially for data. So if you have, let's say, I think the tipping point is somewhere around 0.5 petabyte, the cloud suddenly becomes very expensive. And then running on-prem with the right infrastructure is actually, I would say it's the better choice from a cost perspective, but also from a perspective of keeping control of your data. Because that's the other thing. Migrating petabytes of data is difficult, and it's a huge lock-in for the cloud providers. So keeping your data on-prem under your control is a huge business advantage.
Absolutely. And I can imagine also migrating, the workloads would become much easier, right? Am I right?
Yeah, I mean, if you, so one thing you can do when you have your data on-prem is move parts of your data onto the cloud for temporary clusters. It's basically, ingress is free. Copying out of the cloud is expensive. So a pattern that we see is you start temporary, or you spin up a cluster on the cloud, for example, because they have GPU resources available. You create a temporary Quobyte cluster, hydrate it with your data from on-prem, run your deep learning, and then copy the model back and just tear the cluster down. The model is fairly small, so the egress fees are low. That's a pattern that we've seen.
So also to the point of scalability and performance per meg, I believe this becomes crucial, especially in just like the use cases as you just mentioned. So you talked about life sciences and so on, and now everyone talks about large language models and they talk about AI. So if we want to put that into kind of some examples or some maybe metrics for the people who would manage, probably of course even the AI and the team, like the data scientists and these folks, they should also give their feedback. But if I want to put that into context, so why here scalability and performance became key, and you need to have this approach that you are applying today to have the best results?
Yeah, it depends a bit on the models that you train, but in the end, it's the old story of scale up versus scale out. If you have models that you can only train on a single machine, then it's a question of how many GPUs can you squeeze into a machine, and then you quickly end up with, there is an upper limit and that's it. So what people do is they scale out. So they train smaller models, or they split their models up and train across a large number of machines. And now the challenge is that, let's say you train your model across 100 machines. The data from your storage needs to get into those 100 machines very fast, because the GPUs need to keep on loading the data. So with 100 machines, you suddenly have, you're going broad. Instead of one machine trying to do it very fast, you have 100 machines that need to get it in. So your storage needs to be able to scale out and serve those 100 machines parallel. So one thing that seems to be a challenge for storage admins is that you're not asking for the lowest latency. It's not about, delivering 1 billion IOPS to a single machine, the old transactional database approach. Instead, it's about delivering consistent, high performance to a large number of machines. That's the beauty of scale out. And then your storage system also needs to scale out and basically be able to deliver that.
Now, to this point, and maybe I'm going back to the concept of eliminating the hardware from the formula here. Do you provide also, for example, some best practices? Like, do you help the customers? Of course, you don't sell hardware. You are a software company, but of course, you touch the hardware of the customer in a way. So do you provide also like best practices for them? Like, for example, based on the application that they're gonna use on this storage, so you prefer, for example, to have these models. Do you do these kinds of things there?
Yeah, we have what we call recommended hardware, because we don't really prescribe which exact models you need. But we have, of course, there's the high performance tier, all flash servers. Then we have a mix of hard drive and flash, or the all hard drive servers, and you can get them from any vendor. I think this is our approach, where we say, you know vendor X, you know how to manage those servers, then go buy those servers. Or if you want, the best price, then you let the hardware vendors compete and ask two of your favorite vendors for a price. In the end, the advantage is that the margins in the hardware business are not great, and we let the customers take advantage of that, because the street price for servers is so different from storage appliances. That's why it's an advantage for us to stay on the sideline and say, this is the recommended hardware. The other aspect, of course, is standardization. If you run your data center and you can standardize on less different server models, you make your life easier and you save cost again.
Absolutely. Now, how this affects, like if nowadays everyone talks about savings. So does this help the customer also save money when it comes to, maybe support different hardware, to your point? And also, like, how do you see yourself in, because everyone also talks about now ESG, initiatives and the sustainability and all these stuff. So do you see yourself helping customers with their concerns about energy consumption and sustainability in data centers?
So for the savings, yes. I mean, there's nothing better than commodity hardware, because, as I said, it's a highly competitive market. And so the customers benefit from buying the hardware from that market. The other aspect is what I mentioned with the standardization. We see that a lot these days. If you can reduce, your data center to 3 different server models, your management becomes easier, which reduces your cost. And then also, if you buy a larger number of those servers, which gives you better pricing power. With the green or energy savings, I think this is where picking the right hardware can help. Again, if you talk about AI, your GPUs will dwarf any storage. So we can kind of say, save on the other side. But then, the beauty about scale out is that instead of going with the fastest hardware in each server, you can use servers that are lower powered and then just scale out and have more of them. So if you want to be energy efficient, you can pick servers that have energy efficient CPUs, for example. You don't need to go with the fastest ones. I think the challenge then is NVMe drives, flash. You definitely want to use more hard drives, because surprisingly, those are more energy efficient than NVMe drives.
Yeah, true. Now, you mentioned AI, and of course, we're discussing AI from, AI utilizes the storage. But have you seen any use cases where AI and all, the buzz that's around now affecting, the main functionality of the storage itself? I don't know, because, back in the days, we used to hear about, the auto tiering. We used to hear a lot about, some kind of intelligence in the way how you do priorities for the applications. So are there any advancements, and are you planning or maybe in the phase of doing something that, of course, when I say AI, just for the audience, don't think ChatGPT. I'm not talking about this. I'm talking about AI and machine learning in general. So any specific use cases here, Björn?
Of course, we're looking into it, but I think in the end, when it comes to infrastructure, a lesson that I learned is that you need predictable behavior from your infrastructure. A big problem back in the days was so-called distributed hash tables, anything with hashing, where an admin couldn't really predict how a system will behave. So I think that with storage, I don't know if people really want AI to change how it behaves. Making predictions, alerting, those kind of things, yes, but you want your behavior to be very predictable. So I think, IOPS was a big topic. Of course, the usual suspects like Gartner and so on tried to push that, make it a big thing, but I don't think that IOPS is going pretty exciting. I haven't seen anything exciting in the past couple of years, to be honest.
Maybe another use case that just came to my mind, that this was also kind of a differentiator. Now it's not anymore where the hardware can itself detect that, for example, if a disk will fail, or I'm not sure, like in this space, how things can go into the future.
Yeah, I know. That was also my thought. Predicting failures early on, being faster than smart and whatever with AI sounds good, but then we turned that around anyways with our architecture, where hardware fails. It's just a fact. And you can try to make hardware more reliable by trying to build redundancy and whatever, but that was all expensive and doesn't work well in the end. So we built Quobyte on the assumption that hardware will fail and failure is okay. So we don't really need to predict failures. We can react to failures when they happen.
Yeah, makes sense.
And then you don't need, because smart for years was, smart tells you the drive is going to fail, and then right before it fails. But this trying to predict failures early on, I know that I remember 10 years ago, or maybe there were people trying to put microphones in the data center to identify failing drives based on the sounds and all of that. It's too late. The moment you know that something is going to fail, it's usually too late. So you have to build the system on the assumption that everything fails all the time.
Yeah, so this is where you need to focus on how you have like the better, I would say, fault tolerance, the highest fault tolerance, instead of focusing on these things. So to your point, now you mentioned a lot, Björn, like the what you call it, the scale out architecture, and I worked in multiple times, both on both sides of the table, and scale out architecture is really like, and whoever invented that is genius, right? So. But people always used to question one thing. We say it's a scale-out architecture, but are there any really now, and you come from a computer science background, you had a PhD. So from scientific perspective, when we say we can scale unlimited, is this something real? Or are there like, maybe as we can say, like, it's physics, like law of physics. Like after some time, we need to have like maybe another cluster or something like this. I'm always curious to know and hear it from someone who's into the domain and who studied this deeply. So what you can tell us about that?
It's a very good question. So there are, I think that in distributed systems research it was always this: if it scales to 16 nodes, then it will also scale more. The question is really, where do you get the diminishing returns and what is keeping you from scaling more? And then you have to ask, is it a fundamental limit of the architecture that keeps you from scaling, or is it something in the implementation? So one thing we noticed is that when we have clusters that have 250 nodes or more, we noticed that our monitoring became a bit of a bottleneck. Okay, that's not fundamental, so we solved that problem. It's a different story when you have, typical example is a centralized log service. Whenever you have resources that need to negotiate who's responsible for something, you typically use something like a lease or a lock. And with systems that have like a log service, you always have the problem that, of course, everyone needs to talk to the log service. So they try to make it hierarchical log service with similar problems. So the question is, do you have a component that inherently limits your scalability? Another example is my favorite, NFS. The protocol is designed for clients talking to a single server. When you have NFS in your architecture, you always have those bottlenecks of clients having to go through one or more NFS gateways. So that's a fundamental problem. And if I look at our architecture, we built it in a way that we avoid, for example, central lock service. That was part of my PhD thesis, how to do that in a peer-to-peer fashion to make the system truly scalable. The other aspect was that we said no to NFS. So the Quobyte clients where you consume the storage directly talk to the storage service. So there are no bottlenecks in between. And then the third aspect is like how you deal with scalability, because there needs to be a starting point that everyone talks to, and then the system fans out. And this is where I sometimes call it a federated approach, like a federal state where you have on the top, you have the federal government, and then you go down to the local level, state, local, and this is how you make something scale. We have a similar approach where we have different levels, and then we can scale really big on the lower levels. So far, customers haven't broken that in terms of scalability. So it's still scaled globally.
I think what helps also, and just for people to understand, so the data can grow. So the size of the data will grow, and you need like more storage, and sometimes you need more compute also as well. So the thing that also I think it's helping this, it's a sustainable architecture, because compute is always getting better. I mean, it's getting faster, and even the hardware is having from storage perspective. So you can get more dense from capacity perspective in smaller form factor, if I can call it this way. So maybe that I'm just, because you mentioned the appliances. So maybe if an appliance used to be like giving you a capacity 10 years back of 10 terabytes, now you can have the same size appliance with like maybe same number of compute nodes, 100 terabytes. I'm just giving, making up numbers from my mind. So I think this is also helping actually this architecture to sustain, because always, the compute and storage power is also growing at the same time. They are scaling by themselves. If I'm right, I hope I give a right example here, Björn, right?
Yeah, there is a degree that things are getting faster, but there's a caveat. So, for example, hard drives aren't getting faster; they just get more capacity on a hard drive, but it's still 100 megabytes a second. With NVMe drives, yes, they get more dense, but then the power consumption is now a problem with the large NVMe drives. So it's a bit tricky. I think the power and cooling is still something to keep in mind. But the good thing is when you have standard servers, you can do things like distribute your storage servers across all your racks, which is also great for reliability. But then, you have storage in every rack. You might have balanced it with compute. So you get the flexibility there. But yeah, density is definitely, if you look at those servers where you have 4 servers in 2U, that's actually a highly reliable storage system with high performance in 2U that you can put anywhere. That's pretty amazing if you think about it. Take that,
absolutely.
Edge use cases, just put it in the data center or in your I don't know.
Yeah.
Where you have the IT rack in the store, and suddenly you have a highly reliable storage system where you can do machine learning in the store. The hardware definitely helps us, and also the decline of hardware storage media prices.
Yeah, so I got it, Björn. Like you just try to solve these, I would say, bottlenecks on the software level, and then the hardware become just really now the commodity. It's not like the place you focus on. And for me also, myself as a personal opinion, I'm not big fans of the gigahertz and IOPS and all these, because even when you think about it from benchmarking perspective, these numbers don't tell us much usually. Like they are just numbers, and even when we see some comparisons, okay, so what? Like the question that the customer might ask, okay, so what? Like how this amount of IOs would affect. And to your point, like the important things are to focus on scalability and performance in the way that you discuss it is to minimize the what you call the bottlenecks, right? So 100% on this.
I couldn't say it any better. Yeah, exactly. It's like, people still think in those terms of, I need 1 billion IOPS. but that's not the point. The question is, can you do it in small units? If you do 1 billion IOPS across 100 servers, you can use cost-effective hardware. And the question is, does your storage scale out to those dimensions? We're in a scale-out world where it's more to aggregate, and you don't think in terms of those crazy benchmarks where you try to squeeze the maximum from one machine to have the best benchmark ever. No, it's really the question, can you do it? Can you have a storage cluster of 100, 200, 400 machines that delivers, this, when you go broad, it's like a river. It's like a massive, wide river that transports tons of water per second. Can you build something like that? Does your storage scale out to that? If not, then you're lost in the scale out world.
Absolutely. And just again, sorry, I'm giving examples because it's like something I was telling you, like I work in this domain for a while. So you have law of physics, which are outside actually the storage. So to your point, you just mentioned the hard disk throughput. And also because we still use applications or client server applications, and then you have the network part as well. So if your network, let's say it's 10 gigabit per second, like what, like I have that bottleneck also as well. So 100% on this. Now I want to shift gear a little bit more because you mentioned something that you shifted from being a pure technical person to going out and doing sales marketing. So I would like to know a little bit, like, how was the experience? How did you face any challenges? Or because you were like so passionate about what you were doing, you find out yourself like very like, as you were experienced for real in doing this?
Oh, there were a lot of challenges. The transition is never smooth, but I did realize quickly that I love being in front of prospects and customers. It's exciting. I think founders should talk to their customers and to their prospects, or to the market in the end. I always get a bit, suspicious when founders hide and just do, the technical part, because in the end, you have to listen, you have to understand the market, you have to understand the needs, you have to understand how the customers work. And then, so that took me some time. I had to learn, I learned from our salespeople, and I learned a lot, how you interact with customers. Sometimes you just say no, it's totally fine. Or sometimes you tell them, nope, this is not something we're good at. We're not a good fit, which hurts at a founder because, of course, the software, the product is your baby and you want everyone to use it. But I think for me, it was crucial to be in front of customers, and I still love doing it, And then once the customer's in production and you actually see them use your product, something that you worked on for a long time, it is also very satisfying. The other part is that when it comes to marketing, I think I had the typical techie arrogance. I thought, great product, technology, oh, it's easy. And I had to learn the hard way that marketing it's an art. Sometimes it looks like a black art, black magic. But it is not easy because it involves psychology and it's a lot of trial and error. And so I had to learn a lot about my marketing myself to be able to, understand, is my team doing a good job? Should we try something else? Who do we need to hire? Marketing people are good at selling. So of course, when you interview them, they know how to sell themselves. That's not, criticism. It's just how it works. So you have, as a founder, you have to understand marketing in more detail to understand really, do they know what they're talking about? Do they know how B2B marketing works in a post-COVID world where people don't really work from the office anymore, where, those kind of things. So that was a real challenge. I had to get outside of my comfort zone, which was coding, a lot of times.
Yeah, absolutely. And, I'm one of the people who believe in going out of the building. When founders come to me, I said, okay, we need to go out of the building because, of course, now from some perspective, people ask me, but how do you know this? Because again, when you work as a technology consultant for a vendor in the tech space, so you have the same assumption. Oh, I have the best solution, and the customer. I can't be wrong. The customer is wrong, and sometimes it's not the case. So it's good you mentioned also about I loved your transparency because you mentioned about the arrogance, I would not call it arrogance. I would call it like being a little bit stubborn in opinions to make it a little bit nicer. And assuming like, okay, maybe these people are not getting, or they are not the best fit for me. But for you, you know, like you said, like you had also to change the product to that, to what the customers want, or maybe what the market wants. So that's really good advices. And if I want to ask you, like, if someone today has a pure technical background and, you know, he want to go out or she want to go out, like what other, like, I would say advices you would give to someone who want to become an entrepreneur and start their own companies in the tech space, of course?
I think from my personal perspective, it's immersing yourself in the different areas of the company. You know, it's technology is very important, but it's only one part. As I said, sales, marketing, you need to get an understanding of it and also an appreciation. And you need to find the right people to complement you there, because you will never be the expert. You're the tech expert. You need good people to complement your team there. So I think that's really what I would say from my perspective. Should have maybe done it a bit earlier. Immersed myself in marketing, for example. It's fascinating. You know, it's once you look at it, the problems in marketing are fascinating because it's all about people and psychology. It's the opposite of tech. You're dealing with irrational human beings and try to convince them that your technology is the best. I think, you know, after leaving the comfort zone, I appreciate how much of a different kind of challenge it is. And I think that's why I consider myself very lucky as a founder, that I have the ability to immerse myself in different aspects of the business.
And I think you start to get it more like when you were on the other side of the table and people used to pitch for you something. So I think you start to understand more, oh, now I get these people what they were trying to do, right? So because I lived this feeling when I shifted from one side to the other side of the table. As we're coming to an end, like, any final thoughts you want to tell us? Anything maybe I didn't ask you and you want to highlight about Quobyte, and where people can find more about you and the company?
Yeah, I think you covered, you know, my favorite topic, and I can't believe that, you know, it's 2024 and people still try to wrap their head around scale out. So thank you for covering that, because I think it's really important that people understand that scale out is a different world, and this is where IT is heading. In terms of finding out more about us, we have a free edition that we put out there, so people can actually see that, you know, we really mean that with software storage can be easy. So you can download that from our website if you have servers on the cloud and use it. It's free for production use. So go ahead, see that, you know, storage can be something that you can download.
Great. I'll make sure that to put the website in the show notes. And at the end, thank you very much, Björn, for being with me here today. I love to talk about deep tech, of course, like anything that has, and B2B tech, of course, that people, they don't see. And this for the audience who maybe say, okay, what's this topic? So anything you run today is running on a storage. And, you know, I'm passionate about any technology that can make us, the end user's life, easy in a sense. It's scalable. I know that it's reliable. I know like I would not have any issues when I run my application. So really appreciate the time here today, Björn, and all the nice things you have done, you and the team. Thank you very much. And this is for the audience. So if you just discovered this podcast thank you for passing by. I hope you enjoyed it. If you did so, please subscribe and give us a thumb up and share it with your friends and colleagues. And if you are one of the loyal audiences, or keep coming to me and send me their suggestions and feedback, thank you very much for doing so. Please keep doing what you are doing. Thank you very much for tuning in, and we'll meet again very soon. Thank you. Bye-bye.
Hit that subscribe button, share the show with your tech-savvy friends and fellow entrepreneurs, and leave us a review on your favorite podcast app. Your support means the world to us.